Hey everyone, so I'm gonna walk through the study guide for midterm one. I'm hoping that this will be helpful to you, so you can, well, just get a little bit more of my perspective and how I'm thinking about some of the issues on the study guide. And please do let me know if this is helpful. Okay, so I'm just gonna go line by line through the study guide. Starting off with independent variable and dependent variable. So um, first off, you need to know there's different types of research studies. There's experimental, and then there's broadly non-experimental studies. So in an experimental study, it's really straightforward. The independent variable is whatever you're manipulating. So if you're giving a medication versus placebo, the independent variable is the type of medication. So it's again, that's what you're manipulating. That's what you're controlling in the study. You're directly controlling. The dependent variable is whatever you think that medication has an effect on, depression or binge eating or whatever it might be. And you're saying, okay, this is going to have an effect on this other thing. Now, non-experimental research studies, it's a little different. Because in a non-experimental, there's no manipulation. The experimenter is simply measuring two things, and they're looking for the relationship between it. But generally, you can identify an independent variable and a dependent variable. And there's two main ways to do that. One way is just by sort of pure logic in terms of what causes what. So I find time to be really helpful. So if there's a issue that happens in childhood, and then you're looking at the relationship with something in adulthood, then you could say, well, whatever happened in the childhood is probably the cause, and whatever happened in adulthood is the effect. It doesn't work the other way around, right? So causes come before effects. So the independent variable would be the thing that happened in childhood, and the dependent variable would be the thing that happened in adulthood. So in regards to, let's say, gender. So gender is something, or at least sex is something that gets identified at birth, at conception. And so the sexual identity is determined then. And then the dependent variable is what effect does it have on, cognitive ability, or on personality, or on whatever variable you're looking at. So in that case, the independent variable is sex or gender, and then the dependent variable is the variable that you're interested in. Again, personality or cognitive ability or whatever it might be. So if there's a relationship, the gender or the sex is probably the cause of this other thing, and not vice versa. Um, the um, the other possibility is you just think about theory. For the midterm, I'm not really going to ask you about that, but just for your own knowledge. So if you have a clearly defined theory, oftentimes it says the independent variable is this, and then the dependent variable is that. So for instance, for suicide, an independent variable is being hopeless, and then that can lead to a suicide attempt. So based on that theory, it's not that a suicide attempt makes a person hopeless. It's that the hopelessness can lead a person to attempt suicide. And then we have the mean, median, mode. What are the differences? So the mean is the arithmetic average. You add all the values together and take the average of all of them. So it's the sum divided by the number of observations. The median, you put them all in order from smallest to largest, and then you find the middle. That's the median. And then the mode is the most common score. And whatever it might be. It might end up being towards the middle, or it might end up being at one of the ends. You never know. Okay, then standard deviation and variance. The thing to know there is the standard deviation is the square root of the variance. You could flip that around and say the variance is the square of the standard deviation. That's the main point there. For skewness, so if you, skewness, we talked about it as symmetry. symmetry sort of, does it look like a mirror image of each other on either side of the distribution? If not, then it's skewed. And positive skewness is where on the lower end, you have more of the data, and then you have a tail on the positive end. So the higher numbers have fewer, but they're stretched out further. Negative skewness, you got more of the values on the high end, and then the tail's skewed. Sorry, I'm using my hands, and it might not be in the right direction for you. I apologize. That's from my view. So the positive skewness, the tail is in the positive direction, which again is towards the right, and in negative skewness, the tail is towards the left and smaller numbers. And then you have positive and negative kurtosis. This is how peaked the distribution is. So leptokurtic is where it's got a really tight distribution and it's a big peak. That's a positive kurtosis, is leptokurtic. Negative kurtosis is platykurtic, so it's very flat. So it's like a plateau or like a platypus, very flat. And so the, yeah, that's kurtosis. Then the measurement scale, this is a key one, and I mentioned this. This is something that we keep coming back throughout the class. You have nominal, ordinal, interval, and ratio. Nominal is categorical. It's where you have names, and there's no meaningful order to them. So you may have, like a person may have a preference. So, you know, Italian, Chinese, and something else. But for food, Italian food, Chinese food, American food, which do you prefer? But objectively, there's not like an order to it. That's a subjective order. So it is things like gender, is males and females, like what kind of car brand do you drive? Things like that would be a nominal scale. Ordinal, there's an order to it, but it's not necessarily equal on each level. So it might be ranking, first, second, third through 100th. You don't calculate the mean and standard deviation of a ranking. But another type of ordinal variable is where you have categories, but they do have a sort of an objective order to them. So one example is, I gave this in class, excellent, good, fair, poor. Nobody's going to argue that it goes in that order. Another example would be underweight, normal weight, overweight, and obese. Again, that has an order to it. Those are names, those are categories, but they have an order to it. Interval is a little trickier. IQ and SAT score are interval. So you can calculate a mean and standard deviation. The trick, though, is that they don't have a real zero. And SAT is a really obvious example of this, where you have, it's impossible to get a zero on the SAT. They say you just write your name and you're going to get like a 400 on it. You cannot get a zero. So that's sort of the understanding of interval, is that it doesn't have an absolute zero. Ratio does. So ratio has height. Let's say height and weight are ratio variables. Not to say that anyone ever gets those values, but they make sense. There is a idea of zero height, zero weight. There is a reality to that, and so yeah, that would be a ratio variable. Then frequency, we covered frequency tables. So in SPSS, you do a frequency table and it gives you these things. Simple frequency is just a count. So if you do a frequency table for gender, the count of males, the count of females, but you could also do a frequency table for a continuous variable. So if you say a frequency table on age, you have this number of 12-year-olds, this number of 13-year-olds, 14-year-olds. So this simple frequency is how many 12-year-olds, how many 13-year-olds, how many 14-year-olds. Relative frequency is a percent. So you could do that, a percent of males and percent of females, or you could do the percent of 12-year-olds, percent of 13-year-olds, percent of 14-year-olds. The cumulative relative frequency is where it gets a little bit more um, uh, developed and a little bit more complex. That's the percent of each value and everything above it. So let's say you were for 12-year-olds is 6%. Let's say 13-year-olds is 8%, and then let's say 14-year-olds is 10% of your sample. Well, the cumulative relative frequency would take 12-year-olds, 13-year-olds, and 14-year-olds and add them together and say, okay, there's 6%, 8%, 10%, that's 24% total. And so the cumulative relative frequency would be 24%. Then you have the type of graphs. So if you have a single continuous variable, again, that's interval or ratio, then you would use a histogram. It's like a bar graph, except there's no spaces between the bars, and it just tells you at each within a range on each level of the continuous variable how many people or how many observations are there. So a histogram for a single continuous variable. For two continuous variables, you use a scatter plot. So it's like the relationship between age and you know, SAT score, or any kind of continuous variable. And then if you want a relationship between a nominal variable and a continuous variable, so you could do that with a clustered box plot. So if you had a nominal variable like gender and a continuous variable like how many friends you have, then you can have the females, and you could see the distribution of how many friends they have. Some say they have a few, some that say they have a lot. Then you can look at the distribution for males. Some say they have a few, some they have a lot, and look and see, is there any differences in those? And so that would be a clustered box plot. Then a z-score. Z-score, just think of standard deviation. It's a measure of how many standard deviations you are above or below the mean. Above if the z-score is positive, and below if the z-score is negative. And then the difference between one-tailed and two-tailed hypotheses. A one-tailed hypothesis is saying you have a specific prediction in the positive or negative direction. And a two-tailed, you're saying, I don't know what is going to happen here. I think there's a relationship, but I don't know which direction the relationship will be. It might be positive or it might be negative. And anytime in science, the default's a two-tailed hypothesis, but if I said that there's a specific prediction that it's going to be a positive relationship, or that this group is higher than this group, then you would assume a one-tailed hypothesis in that case. Otherwise, assume a two-tailed hypothesis. Okay, so be able to identify the null hypothesis. So if you say one-tailed hypothesis, I think that this group is going to be higher than this group. Well, then a null hypothesis for that. So that's the alternative hypothesis, that this group A, is greater than group B on some variable. But the null hypothesis would be that it's either that there's no difference between group A or group B, or that group B is greater than group A. So it's all the alternatives are covered under the null hypothesis. The null hypothesis for a two-tailed hypothesis is more straightforward, because you're predicting it's either going to be group A is greater than group B, or group A is less than group B. So the null hypothesis is right down the middle. There's no difference in the means of group A and group B. And then you have the alternative hypothesis. Well, just know that the alternative hypothesis is your hypothesis for a research question. So if I say that I think that there's this relationship, that is your alternative hypothesis. And then the relationship between p-value and significance, just know that p-value is an indicator of significance. So if it's a p-value less than 0.05, you have a significant result. If it's a p-value of 0.05 or greater, you say it's not significant. All right, so that's pretty cut and dry, the basics. Hopefully this has been helpful, and hopefully you'll do well on the midterm. I'm rooting for you guys. So good luck studying. All right.